In each of the following cases, exercise 11.3, last exercise on 3V, that determine the direction cosines of the normal to the plane. Direction cosines of the normal to the plane and the distance from the origin. Direction cosines means if we take, okay, first we will take B. Our plane is x plus y plus z is equal to 1. So this is ax plus by plus cz is equal to 1. If we divide by under root a square plus b square plus c square, because here a is what, 1, b is equal to 1, c is also equal to 1. If you compare this is the equation of a plane ax plus by plus cz is equal to d. General equation of a plane, and dr, abc are the, these are the drs of the plane, drs of the normal to the plane, drs of the normal to the plane. Drs of the plane are said to be drs of the normal to the plane because there are no drs for plane. That is the drs of the normal to the plane. Normal is a perpendicular line on the plane, so that's why it will have the drs, and plane is not a line, so that's why this is dr. So in order to make the dc's, we will divide it by under root, find the value of under root a square plus b square plus c square. So you will get 1 square plus 1 square plus 1 square, that is equal to root 3. So root 3, divide this equation by root 3. Divide equation number 1 by root 3, we get 1 by root 3x plus 1 by root 3y plus 1 by root 3z is equal to 1 by root 3. So this is converted into the normal form now. Now it is in the normal form, and direction cosines are, therefore direction cosines are 1 by root 3, 1 by root 3 and 1 by root 3. And the distance from the origin, when you convert it into the normal form, this distance will become the distance from the origin. Therefore, the distance from the origin will be equal to distance from the origin is equal to 1 by root 3. Okay. So like this, we can have all the questions. In A, if x is not given, you can write 0x plus 0y plus z, that is 1 into z is equal to 2. Okay. So you will get under root 0 square divided by 0 square plus 0 square plus 1 square, that is 1. So divided by 1 is same. So therefore here also DCs will be equal to, DCs and DRs are same because some of the squares is 1, and that is the property of a DC. So DCs are here 0, 0, 1, and also they are normals. And the perpendicular distance is also D, if we denote the, okay, perpendicular distance from origin is equal to 2. Okay. Similarly, we can do for all other questions. This will be divided by under root 2 square plus 3 square plus minus 1 square. That is equal to, this is question number C, under root 2 square 4, 3 square 9, 1 square 1, 9, 10, 14, under root 14. So divided by under root 14, therefore DCs will be equal to, DCs are 2 by under root 14. Are you understanding? 3 by under root 14 and minus 1 by under root 14 and perpendicular distance from origin is equal to 5 by under root 14. Distance is positive. That is question number 1. Equation of a plane which is at distance 7 units from the origin. That means x-axis, y, z-axis, y-axis, x-axis. So this is so that plane, wherever it is, this plane, suppose this is a plane. Okay, okay, suppose. So from here to this plane, there is a point from this plane like this, it will come out. So that is the perpendicular distance from the origin OP. So that is given 7 units. Distance from the origin. This is OP, that is we used to say D. So here D is 7. Okay. And normal to the vector. Normal to the vector. This is not the unit normal. This point is very important. Normal means any normal on this vector, on this plane. This is a normal on the plane. Okay. This is a normal to the plane. Okay. So this is a normal to the plane. It is normal to the plane. This is denoted by N. N. Okay. This is denoted by N vector N. Okay. This N vector is given as 3i plus 5j minus 6k. But here if you see that this is the condition of the equation which is at a distance from the origin. This is your y-axis, z-axis and x-axis. So this is the condition that when we use the equation of this plane should be in the form of r dot n cap is equal to d, because this d we are using on d, same d, but when it is n cap, then this d will become the distance of this plane from the origin. Otherwise actually this is wrong. It should be perpendicular. So the OP should be perpendicular. So now this n should be converted into n, and we can use the formula of this, because this is the condition of that one. So what we will write, we should write like this: let the equation of a plane be r dot n is equal to d. And they have asked vector equation, not the Cartesian form. So that means n, either you use capital N or small n. It doesn't matter. We can use the small n, because we are using a small n, so we should use the small n. So use small n. Okay. So now we have to convert n into unit vector, and you know that how to find n cap. N cap is equal to any unit vector is equal to vector divided by its magnitude. So here vector is 3i plus 5j cap minus 6k cap and divided by its magnitude. Its magnitude is what? Under root 3 square plus 5 square plus minus 6 square. So this will be 70. So you will get n cap as under root 70. It will be under root 70. So we can write n cap is equal to, therefore n cap should be written in this way, 3 by under root 70 I plus 5 by under root 70j. We should write in the resolved form minus 6 by under root 70k. So as it is converted into the unit vector, these are the DRs of this vector. If you will square and add them, L square plus M square plus N square will come to 1. That's another thing. So now this value you can put in first, we get the answer. And D is already here, N is this one, and D is given 7 centimeter. So substituting in first, put in first, we get the answer. Put in first, we get the answer R dot, and R is always, you know that R is what? Xi plus Yj plus Zk. So when we are writing the final answer, we can use instead of R, Xi plus Yj plus Zk dot n cap dot. N cap is 3 by under root 70 I cap plus 5 by under root 70 j cap minus 6 by under root 70 k cap is equal to D, and D is 7. So this is the vector equation, which is the required equation of the plane in vector form, which is the required equation of plane. Obviously, it is in vector form. So if you have to convert into the scalar form, you can find the dot product. It will convert into the Cartesian coordinate system. But here it is as vector form. That's it. Okay. Here, just you have to convert it into the Cartesian equation. So you can put just value of R. Value of R is what? Xi plus Yj plus Zk. It is with the dot product of S minus 2Ti plus 3 minus Tj plus 2S plus Tk is equal to 15. Okay. Dot product means the coefficients of I will multiply together. X will multiply with S minus 2T and plus Y will multiply with 3 minus T and Z will multiply with 2S plus T is equal to 15. That is converted into the Cartesian equation because there is no ijk. When ijk is not there, that means it is converted into the Cartesian equation. That's all. Now you can leave it like this, or you can bring 15 this side, but this is the Cartesian equation of the plane, which is the Cartesian equation of the plane. So whenever, any time, in any case, if you have a vector equation, you put the value of r and find the dot product, always it will convert into the Cartesian equation. This is the Cartesian equation of the given plane. Okay, so B and C part you can do it. Now we have to find the foot of perpendicular of the origin. So from O origin we have dropped a perpendicular. This point P we have to find the foot of the perpendicular, and equation of this plane is 2x plus 3y plus 4z minus 12 is equal to 0. Equation of plane A, question A we are doing. Equation, first we will write the equation of a line OP. Equation of a line, you know that, what will be the, it is the perpendicular on the plane. So drs of this line will be the drs of the plane. So drs will be same. So drs will be for this line. This line, I'm talking about this line 2, 3, 4. Same, because this is perpendicular. So any normal has the same dr that the plane shows. The normal drs of the plane are the drs of the normal, and it is also normal. It is not looking normal here. It should be, but this is normal. Okay, you cannot make it here. That's why. Otherwise, you can understand this may be the tilted plane, not perpendicular to z axis. Should be something like this one. So got it. So this is the dr. So equation of a line passing through the, so let equation of, we will do like this, let equation of OP line OP B. It is passing through the origin x minus 0 and dr 2. You know that the equation of a line passing through a point is what? X minus x1 upon a, y minus y1 upon b, and z minus z1 upon c. A, B, C are the drs of that line. So here drs, we know the drs are A, B, C here. In this case, A, B, and C, these are the drs, and this is the point from which this line is passing. That is origin x1, y1, and z1. So its equation will be y minus 0 upon 2 and z minus 0. Sorry, not 2, 3. 2, 3, and 4. Z minus 0 upon 4. 2, 3, and 4 are the drs of this line 2, 3, and 4. Achha, whenever we have to find any point on this line, if we equate it to lambda, just you have to remember that any point if we have to find on this line, we will equate to lambda, each one separately equated to lambda. Because of 0, we are getting directly x is equal to 2 lambda. Otherwise, we have to equate it and solve it, and y is equal to 3 lambda and z is equal to 4 lambda. That means this is a point, any point on the line OP. Therefore, 2 lambda, 3 lambda, and 4 lambda is any point on this line, any point on OP. Let it be the foot of the perpendicular. So this point we can take, let this point take as P, because P we have taken the foot of the perpendicular. So we can say that P is any point on the, so this P, let this P be the foot of the perpendicular. So let point, this point we will suppose as the foot of the perpendicular. Let point P be the foot of perpendicular OP. So therefore, this point lies on this line, on this plane, 2 lambda, 3 lambda. So it will satisfy the equation of the plane. So therefore, P lies on plane, lies on plane. So therefore, we can put the values of P on the plane. So 2 into 2 lambda plus 3 into 3 lambda and plus 4 into 4 lambda is equal to 12, and solve it. We get the value of lambda, and you can what we have to find foot of the perpendicular. You can put again the value of lambda in this point, you will get the answer. So we have less than 1 minute, so we will continue in the second part this question.